Okay, class, we're in chapter 5, lesson 7. We're working on problem number 6, and we're given here a different type of problem. Chicago and London are 3,960 miles apart. Okay, and we're given a table here. It says copy and complete the following table to show how long it would take to fly from one city to the other. And we have speed in miles per hour, and we have time in hours. And we see here that the speed is increasing by 50 miles per hour each time. Now, let's stop for a minute and think. If I'm going faster, will it take less time or more time? Well, the faster you go, the less time it takes. And if you think of if I have to travel 1 mile, okay, and now we're traveling at 3 miles per hour, okay, think of the time it would take for me to cover that. Now, if I were going 6 miles per hour, now you would think that the person that's traveling 6 miles per hour is going to travel that mile faster, wouldn't they? In fact, they're going to get there in half the time because I'm going 3 miles per hour and they're going 6 miles per hour. So, if you really stop and think here, this plane is traveling faster in each of these values that were given here, the speed of 400 all the way to 550. So, what's that relationship in the equation and how does it affect the time? Well, that's what we're going to work on here. And we're told here to now calculate or to complete the table. And if we just simply plug this into our 3,960 miles, now that's the distance, this is our equation we're working with, that's going to be equal to the rate times the time, right? Now we know the rate right now in each of these are going to increase by 50. So we're going to start with the 400, and if we took each of these sides and we divided, right? I don't think I even have to say that now. You've already learned that. You know we're solving for t, so we just divide because we're multiplying by 400 and we're dividing by 400. And what would we get? Well, in this case, we would have t is going to be equal to 9.9. Okay, now if we did this for each of these times, we're going to notice that it goes from 9.9 down to 8.8. Then our next one is going to be 7.92, and this one would actually be 7.2. Now, whether it's 7.92, you could put 7.9. We're noticing what's happening is that this is actually going down. The speed is decreasing the time that it takes to travel this distance. So as this is increasing, right, this is increasing, this is decreasing, what do we call that? And that's the question that we have in, well, actually that would be letter C. I'm jumping the gun here. But letter C does say, how does the time vary with respect to speed? And we know that when something's going up and it's affecting something going down, we know the word here is it's an inverse, right? It's affecting it inversely. So that would be our answer. But let's go back to B. Write a formula from this table letting R represent. And we had done that already. We started here. We jumped into that actually directly. We had 3,960 is equal to the rate times the time, right? And but we want to solve this for t. We want to be able to see what a formula. We want to write a formula for this table, and we have to know what t is because that's what we're solving for. We didn't know what t was. So what would we do here is we simply divide this by r, wouldn't we? So we have r over r is 1, but what we do to one side we'll do to the other. And that means t is going to be equal to 3,960 divided by r. So that would be our formula. So if we know what r is, and in this case we were plugging in the value 400, all right, we did that over here, and you saw how we were dividing by 400 to get 9.9. And this is simply the formula we would have been using. We would have divided by 450, by 500, and by 550, and we would have gotten these corresponding answers. So that is number 6.